Okay, here we go. We've got a question about a circuit. I got a little bit worried here that it wasn't relevant to you guys. However, this very much is. As ever, hit play when you're ready to see an explanation of the answer. Okay, so as I alluded to, there used to be a part of this the syllabus called Kirchhoff's laws. I thought this was to do with that when I first saw this question. It looks very much like a Kirchhoff's laws question, however, it is not. We're going to try and work out some equations which allow us to determine more about the circuit. Okay, now I think the key to this is to recognize what type of circuit this is. This is a parallel circuit. Okay, and then we write down the rules. So let's think about this first. It's a parallel circuit. Now normally we would have R over here. There's nothing different there. We have a parallel circuit. We could easily move R here and the behavior would still be the same. So what does that mean? Well, it means the potential difference across these guys is the same. Okay, anywhere in a parallel circuit, we've got this branching off. The potential difference across here must be equal to the potential difference across here. It's actually equal to the EMF because we've only got one cell in the circuit. So the voltage here, or the potential difference across each of these, is going to be the same. The other thing we're going to acknowledge is that the currents add up. I1 equals I2 plus I3, and that is going to be super important for the rest of this part of the question. Let's work with this. Let's firstly determine the potential difference. Well, potential difference given by Ohm's law, V equal IR. Therefore, if we just go through this, we'll look here, we've got the potential difference over R, that's going to be I3 times R, is equal to I2 times 3R. We're just using V equal IR here. And we can cancel the R's so that we have this final equation here, I3 equal to 3I2. And I'm pretty sure we could start getting rid of something. We could get rid of C now because that says 4. It's actually a 3. We're then going to take this equation and put this one in. I1 equals I2 plus 3I2 equals to 4I2. In other words, the answer here is B. Okay, so you notice here that we're using those equations, those rules, of a parallel circuit in a slightly different way to get a relationship between the currents in the circuit. As I say, I think this is very Kirchhoff light. I think you may not have had a lot of training on this, so by all means, take some time on it to make sure you understand how I've worked that through, and any questions, please let me know.